Humans have been making things out of copper longer than any other metal. Archaeological digs around the world have unearthed copper vessels, tools, weapons, and jewelry dating back at least 10,000 years. Fast forward to today, and copper is one mineral we still really dig. Peel back the layers of modern civilization, and there's a lot of copper. It's used for electrical motors and wiring, high-tech gadgetry, and plumbing. The metal known chemically as Cu is essential to modern living. Pure copper is rarely found in nature. It usually occurs with other elements like iron and sulfur. To mine the copper-bearing rock, a huge drill chews into this Arizona terrain. It drills around 130 holes at least 15 meters down. A truck pumps explosives into them. It's a powerful mix of ammonium nitrate and fuel oil. A mine worker lowers electronic detonating devices into each of the 130 holes. From a safe distance away, he activates the detonators, staging the explosions milliseconds apart. It's an explosion sequence designed to fracture as much of the copper-bearing rock as possible. Shovels scoop up the blasted rock, lifting 50 to 80 tons in one bite. The rock is less than 1/2 of 1% copper. Freeing the copper from it involves different techniques. The technique depends on whether the ore is iron oxide based or sulfide based. To process copper from oxide ore, they pile the rock in specially prepared leaching areas. They irrigate the rock with a diluted sulfuric acid solution. Over months, the solution percolates down and dissolves the copper. The copper solution drains into a pond. A pump transfers this solution to the plant. In this channel, the copper solution binds with an organic agent and floats to the top. They add an acidic solution, which increases the concentration of the copper and makes it electrically conductive. They transfer the copper solution to a series of tanks that contain starter sheets of pure copper called cathodes. They pass an electrical current through the tank, and the copper migrates to the cathodes. At the outset, the cathodes are wafer thin, but over a period of 10 days, they thicken substantially. They're now 2.5 centimeters thick. Each one weighs about 125 kilograms. The purity is now 99.99%. That's important if the copper is to be processed into electrical products. Freeing copper from the sulfide rock is more difficult. It starts in a massive tumbler called a sag mill. Inside, steel grinding balls smash wet rock to pieces. Exiting the mill, the smashed rock travels over a perforated conveyor to screen out smaller pebble-sized rocks. These smaller rocks continue on to different grinding mills. The larger rocks circle back to the sag mill for another round. Once all the rock has been sufficiently ground, they add chemicals, which coat the copper particles and mix in a frothing substance. The slurry flows into flotation tanks. Air blasts create bubbles that the chemically coated copper minerals attach to. The bubbles carry the minerals to the top of the tank and they overflow. After filtering the overflow, they have a concentrate that's now 25 to 30% copper. They transfer the concentrate by rail to a smelter facility. Here it goes into several large beds. Each one is the size of 2 basketball courts. They add silica sand, creating a layer cake of sand and copper concentrate. The silica sand is known as a flux. It will serve as a purifying agent as the concentrate is smelted. In the intense heat of the furnace, the silica sand melts to form a slag that absorbs the iron and other unwanted minerals. The slag floats up and the copper sinks. Its purity is now 60%. Then it's into a second furnace, where they up the copper content to 98%. Coming up, there's much more to the story of copper. There are networks of copper in the walls of modern buildings, wires and pipes that supply utilities and keep the household humming. Hidden behind drywall, it's easy to overlook the contribution of this thermally and electrically conductive metal. But behind the scenes, copper is a big player. With the copper now extracted from the ore, they pour the residue onto a heap. This molten slag flows down like lava from a volcano. As it cools, it becomes part of the landscape. Meanwhile, in the smelter, a crane delivers the fiery liquid copper into another furnace for further purification. Inside this furnace, the purity level increases from 98% to 99.4%. The molten copper flows out of the furnace and into rotating molds. The molds shape the copper into big rectangular slabs called anodes. The slabs will serve as positively charged electrodes in the electro-refining process that's still to come. That process will take the purity level up one last notch. The copper begins to cool in the molds. A sprayer douses them with water to speed the cooling process, and the copper hardens into the anode shape. A hydraulic cylinder pops them out of the molds. Then a carrier system retrieves them and takes them for a rinse. This gets rid of any traces of a non-stick substance applied to the molds earlier for easy release of the copper slabs. Hooks formed during the molding make it easy to rack up the slabs for shipment to a Texas refinery, hundreds of kilometers away. At the refinery, the copper slabs shed any lingering impurities in this tank, as an electrical current is applied. The current causes the copper to gravitate to thin starter sheets. The impurities fall to the bottom. The copper deposited on the starter sheets is 99.99% pure, the purity level required by wire manufacturers. They load it into a furnace that's essentially a tall shaft. Midway down, the pure copper melts and flows to the bottom of the furnace. From there, they transfer it to an insulated metal channel, which keeps it molten as it now travels into a vertical mold. This mold shapes it into rectangular forms known as copper cakes. Copper cakes are used for manufacturing things like copper sheeting and plumbing parts. Fresh from the mold, the copper cakes are roughly 6 meters long. A conveyor serves them up to a circular saw that slices them to lengths required by the customer. Stacked and labeled, this pure copper cake is now ready to ship to the manufacturer. They also process pure copper into rods, a form more suitable for manufacturing electrical wiring. Molten copper moves through an opening in a mold, and, cooled by water, the copper forms a continuous rectangular bar. These grooved rollers will now take it from rectangular to round and reduce the diameter substantially. As the copper travels through the grooves, it becomes an 8 millimeter thick copper rod. The rod exits and the machine loops it into coils. They land neatly onto a steel spool. Machinery compresses the copper coil, squeezing it down so it will take up less space when it's transported. There's one last squeeze from an overhead press. And an employee ties the tightly coiled copper with extra strong plastic banding. From the Earth's crust to the factory floor, it's been quite a journey. Shipped to manufacturers, it will now be drawn into electrical wiring, and the future is sure to be high voltage.